you might be inside of a black hole. That's 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 inside of a black hole, and so on. In fact, everything that exists, it could be black holes all the way down. But black holes break our understanding of the universe more than it's explained. This is a video about black hole universes, their theoretical existence, and some surprising discoveries that could shift our world. This is the New Prolectron New Year's Special. Let's first make a black hole out of air. So technically, here's a banana. Anything can be a black hole if you squeeze into a finite amount. You need to squeeze Earth to the size of a coin for it to be a black hole, the sun to the size of a small city for it to be a black hole, and when enough mass is concentrated into one space, you get something super dense. This is how black holes are usually explained. Stuff gets super dense, and then it collapses into a black hole. But actually, you don't need a lot of mass and density for black holes to form. We're ignoring some maths here, but all we really need to know is that the bigger the black hole is, the less dense it is. So very massive black holes are actually very thin. Let's see this. A black hole with one solar mass is about 6 kilometers in diameter and has the density of one. Let me see if I'm capturing this. Yeah, it has a density of 1 Himalayan range per cubic meter. I should probably remove. So yeah, Sagittarius A star, the black hole inside of our Milky Way, has a mass of 4 million suns. So I'll just put this. It's 24 million kilometers in diameter and is as dense as 6 blue whales per cubic meter. You see, it's getting less dense. The ultra-massive black hole, Iris 2100-4156, has a mass of 3.8 billion suns and is as wide as the solar system, which is about 110 or 100 billion kilometers in diameter. But because of its density and because of its incredible mass, it's only as dense as air. So that means if you were to take a balloon and fill it with undecillionths of amounts of air, once it reaches the size of our universe, it will collapse into a black hole. Okay, we got all that. Now, let's think big. What would it take to make a black hole the size of the universe? We have concluded chapter 1, how to make a black hole out of air. Now let's move on to chapter 2, a universe-sized black hole. Ooh, scary. So, the entire observable universe has the mass of 100 septillion suns. But because of its incredible mass, it's so very not dense. If you blended the entire universe and then poured it all out, all the stars, galaxies, and stuff like that, it will only be as dense as 5 hydrogen atoms per cubic meter. The universe is a sphere with a radius of 45 billion light years in every direction. For context, radius is anywhere from the center of a circle to any of its sides. So 45 billion light years in every direction. This is the formula for diameter. Very easy to figure it out. It's just length. But anyways, we think of this as some sort of cosmic air that separates the regular air. So if we blew up a balloon the size of the universe, it would make a black hole. Actually, it will make a black hole 10 times bigger than the entire observable universe. But that could only mean one thing. We're living in a truly gargantuan black hole. Like right now. But how this could be true. However, the universe is expanding. Something that you wouldn't expect to see in a black hole universe. So universes can't be inside black holes, at least not in the cheesy way we explained. To do this, let's jump inside a black hole and die. Chapter 3. A universe born inside of a black hole. I'm literally sweating right now. Probably because of room temperature or something. Okay. So we think of the black hole's singularity as an infinite point of density where our entire understanding of physics breaks down. But it's wrong. Oh no, they're so much weirder than that. So, inside of a black hole, time and space pretty much switch places. So basically, inside of a regular sphere, space is finite, so limited, but time is infinite. So it goes on forever. And a black hole is the opposite. Space goes on forever, but time is finite. This doesn't make any sense, but I promise it will. So imagine you're inside of a black hole. Space goes on forever. You could walk in one direction and keep going forever, or walk in a different direction and end up where you started. However, time is finite and it's now running out. Reality kind of gets bent and warped when you're inside a black hole. So you get smaller and smaller and smaller and smaller until eventually, bam! You get squished into an infinitely dense point, eventually swallowed by the singularity. So the singularity is not a place you can go. It's not in this. So a singularity is not inside of a black hole or any other direction. It's in the future. The singularity is not a place where you can go. No, it happens. It's an event in time. Once you reach the singularity, it's all over. Time, space. What are these things? None of it matters anymore. Some kind of stop existing in a way. So, is this the end? Well, no. This is you getting squished down is one of the scenarios of when our universe will end. The Big Crunch, where a very, 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 very long time after the Big Bang, the universe crunches down back into a singularity. But if there's a Big Bang, then there should be a big crunch. Like a rubber ball, you squeeze too hard and then it rebounces. Space might start expanding again. So if you take all that into consideration, you could have a universe born inside of a black hole. But that could lead to, lead to these black holes being in other universes preserved by bigger and bigger black holes. And then universe families with the longest, with the most universes end up surviving the longest. It's like survival of the fittest, but instead of animals, it's universes. I know you can't see all of it, but here it is. And eventually these universes will die out. So, is this true? Well, we don't know. Yeah, this is based on real science, but really, we don't know about this. Black holes don't explain why the universe happened or why it is the way it is. Instead of questions like this providing answers, it just leads to more problems. Just like Albert Einstein once said, you can't solve a problem without creating 10 others. So we don't know if this is true. But if it is, think about the survival of the fittest thing again. Life may live on forever. But of course, none of this is true. Or is it? We just ended chapter 4, which is black hole universes and stuff like that. Infinite black hole universes. But now let's move on to chapter 5, aka chapter extra, if you might say. Actual research that may lead this to becoming a reality has to do with research from last year conducted by JWST, aka the James Webb Space Telescope. This guy is absolutely amazing. We have absolutely great pictures of our universe. Infrared, may I add. Wavelengths we can't see, but that's a story for another day. It was on a survey. It studied 300 galaxies, millions of light years away. Really, it wanted to see if how many galaxies were spinning clockwise and how many anti-clockwise. According to the calculations, half should be spinning clockwise and the other half counterclockwise. But no, it was discovered that 2/3 of the galaxies were spinning clockwise. And as this paper states, if something may be causing these black holes to be, may be causing these galaxies to be moving in such that specific way in that specific number. Black holes. But wait, black holes can rotate? What the hell? Well, they can. Non-rotating black holes are called Schwarzschild black holes after Karl Schwarzschild. Karl Schwarzschild, which made the formula for the Schwarzschild radius and also solved Einstein's field equations. So those are non-rotating black holes. Meanwhile, rotating black holes they exist and are called Kerr black holes after famous physicist Roy Kerr, which solved Einstein's field equations for the rotating case. So but how can this be possible? How can I look at the singularity? It's a single point. Well, the singularity of Kerr black holes is not this, but rather this. This is the singularity of a Kerr black hole. It's a ring, which means you could fall through it. There's also more complexity with these kind of black holes. I recommend checking out Veritasium a famous YouTuber Veritasium for all this information. But basically, if the singularly occurring black holes is a ring, then the Big Bang could have been a white hole in the skies. White holes are basically the opposite to black holes. Black holes, everything must enter, but nothing can exit. Here it's the opposite. Everything must exit, but nothing can enter. They are theoretically possible, as stated by Einstein's equations, but we don't know if they exist. So, in summary, black hole universes are theoretical, and based on JWST's awesome research, this could be a reality, changing our perspective of the universe entirely. So, black hole, thanks for staying with me through this stupidly complicated question. You are watching Noob Electron, and as always, thanks for watching. Also look at the setup I used. I stacked these things on top of each other, used some Osmo equipment, put a speaker here, and also followed the entire thing using this picture essay that I made last year. Okay, bye.